aspects of scrutiny in the work. So it's a system of instructions. It's one layer removed from computer code. So this is the basic element in the system circle. This is the first behavior. Do you move in a straight line? The second behavior is constrained to surface. The third behavior is change direction while touching another. And the fourth behavior is move away from an overlapping element. So we condense these behaviors together, we aggregate them, the form plus behaviors, and that forms element 1. We condense that, nice reduced notation, and then this is a diagram of element 1 in action. So here you can see the behaviors executed. It becomes easier to read when we make a note of each behavior. So this is move in a straight line. You can see that when they're not touching another element, they're moving along a straight vector. This is rotate while touching another. Here we have move away from the center of overlapping elements. And so in basically making this diagram out of these instructions, we make a number of assumptions. So if we change the parameters and then rerun, you can see how the system unfolds in a slightly different way with these modified numbers. Again, we can change the parameters. So this is, again, element 1. And this is element 3. Element 3 uses a line as its basic element. And we have the addition of behavior 5, which is enter from the opposite edge after moving off the surface. So this makes a toroidal geometry in a conventional plane. This is element 3 executed as a diagram. So you can see they move along a straight line. When they're overlapped with another, they begin to rotate. And we're skipping around. We're jumping gears here. And this is a few different assumptions running element 3. And then again, this one's even more different. So one thing I'm really very, very interested in is this idea of interpretation. So you have this instructions written in English, and then you make it into code. There's a lot of interpretation that needs to happen between that step. One thing I'm really frustrated about writing code is there's really no room for interpretation there. The computer does exactly what you tell it to do. So moving away from that and writing these instructions in English first allows for interpretation. It's kind of the difference between, or the analogy I like to make is a musical score. A musical score is the final work of the composer, but of course when that composition is performed, there's a lot of interpretation made by the performer. It's a different work every time it's performed. So I'm interested, the computer being such a strict system, in allowing for that kind of flexibility. Element 5, which is variation. The variation here is behavior 6 and 7, where we orient towards the direction of element that's touching, and we deviate from our current direction. So a little bit of noise in the motion. So this is a set of instructions that approximate the blocking, but through a more minimal instruction set. And you can see the difference here clearly between element 3 and element 5, that they begin to group together as time passes, as they're trying to search for a common heading when they're overlapping with another. So this is the full library. So over the years, we've worked with these 2 elements, these basic behaviors, and to make these 5 different elements. And so from that, this has really been an exploration in finding the most minimal expression or group of instructions to produce the maximum amount of diverse results. Another obsession in the work is the relationship between the artificial and the organic. So this idea of making these very precise, minimal, clockwork-like pieces of geometry that produce something which is unexpectedly organic in nature. But still, underlying that, you can see very much synthetic root of it all. So this is process 4. A process, in my sort of terms, is a way of visualizing an element. And so we start off with a random even distribution where all of the elements are put around the screen, kind of with even space in between. And then over time, order begins to emerge as they follow their behaviors. So you can now start to see it resolving. So this is how the processes are described once again in English to allow for this flexibility. So here we say, a rectangular surface filled with varying sizes of element 1. Draw a line from the center of the elements that are touching. Set the value of the shortest possible line to black and the longest to white with varying grays in between. So if 2 large circles are touching, that line is going to be white. If 2 small circles are touching, that line is going to be black, and all the gradation in between. So with these simple instructions for the behaviors, and this way of making that visual through the description of the process, we're then able to create myriad different pieces by making a few different assumptions or decisions and putting that into source code. Here we see a different parameter set for process 4. All right, moving on. So from that, I think of that in a way as my basic research. And then from there,